What's up everyone? Today I want to talk about this news that's broke out all over Twitter and all over social media, as well as security vendors and everyone in InfoSec has been talking about, which is the new vulnerability found in Citrix ADC, also known as the Netscaler ADC. I'm actually looking at an article on the side right here where it talks about the vulnerability, how people have been patching it since it's been released, and also gives you some details about the vuln itself. So if you're not familiar, this is CVE 2019-19781. Again, this allows a remote attacker to take over this box, and on top of all of that, not only they're able to read local files and execute commands on this machine, but because of the nature of the application itself, it also allows the remote attacker to gain access to the internal network as well. So today I want to look into it and see why is it such a big deal, how many machines out there are vulnerable, how to exploit it, and how to actually fingerprint for this particular application, kind of evaluate this entire vuln. So let's get into it and find out what is this hype about. So according to the National Vulnerability Database, this was given a severity score of 9.8 critical, which is on the super high end of a CVSS score. And based on all the information that I'm seeing over here, it looks like anything from version 10.5, 11.5, 12, 12.1 and 13 are vulnerable to this attack. So it kind of makes me think that the numbers of machines out there that are within these versions are on the high end of thousands of machines, and obviously the more companies use it, the more important this vulnerability becomes. Also looking at this site, it looks like Citrix has addressed it. They have sent out their advisory already. So just simply searching the CVE number on Twitter, I can see a ton of high profile people with bug bounty hunters, red teamers, and any InfoSec professionals talking about this. I've seen people like Dave Kennedy, Kevin Beaumont, Orange Sai, tons of other people talk about this vulnerability, and I kind of want to understand why it's such a big deal. So doing some research, again, as I mentioned earlier, this is a vulnerability that affects a service where it gives access to internal network. So in case of a bug bounty hunter where we find an SSRF, it's obviously always exciting news because the SSRF usually leads into giving access to internal network. So for this case, it's also the same kind of, because not only you're able to exploit this machine, but this machine is what separates the outsiders from the insiders when it comes down to the organization. So if you have a remote command execution on this machine, as this vulnerability is described, then obviously you can do more than just read files, as well as access to other internal resources. The first thing that I've seen is TrustedSec has put out a working proof of concept for the RCE part. Also Corbin, aka CDL, he has pointed out the LFI to RCE and also how simple it was to reproduce and get a working POC for. And I want to also look at it from my perspective of how many machines are out there, how do we actually fingerprint for this if we're masking the entire internet, and also how do we exploit it. So to do all this, a big shout out to Corbin himself. He actually hooked me up with an instance of the Citrix app, the ADC. I'm going to pull it up, play with it, and see what we find. So let's check it out. When it comes down to identifying this application, there are a various number of ways we can do that, but based on the title itself. So when you go to the web page for any ADC applications, the title is always set as Citrix login. So if you just plug that into Shodan, I'm looking at it right now on the side monitor, there are over 8,000 identified machines that have the title Citrix login on Shodan. So if I look at the other ways to scan and identify this application, I can almost guarantee there are more and more boxes out there that are vulnerable. So according to Tripwire, which I will put the link down below, they have claimed that 80,000 plus machines are vulnerable to this. And I think Shodan has also launched a monitoring for the CVE number. If you have the monitoring set up, it will send you alerts, but it seems like this is getting bigger and bigger as we go. So I really want to dig into this and find other ways of identifying this vulnerability and also identifying applications like this one, being Netscaler, Citrix ADC, and see how do we actually fingerprint for it. The first thing I noticed, again, I mentioned earlier, is the title. The title is really unique. It gives away that this is Citrix ADC, and you can kind of see it on the top left corner of my screen. And again, we can do things like open up the web page source and look at the files that make this identifiable and unique to Citrix ADC. So the first thing I realize is the CSS file. So if I were to parse every single HTML page that I've scanned, so let's say if I'm scanning the whole internet and I'm parsing every single web page, then just based on the content of the web page alone, I can identify this application easily based on the CSS files, some of the JavaScript files, and the keywords that have been used within the page. That's always a good way of identifying them, but it's not efficient, and it's also not as easy because that means you have to parse every single page and also create some workflow where you're identifying if these files exist, and you have to account for false positives as well. But again, looking at this page alone, a few identifiers for me would be the CSS file, looking at the fact that it mentions Citrix a number of times, and also looking at the response headers. So if we go to burp and we request this page, just doing get space / to the host that we're testing without anything, we can see that it doesn't give us too many identifiable headers. But again, if we look at it, there are some mentions to citrix.com, cis.citrix.com, which is also a way for us to create as a part of our fingerprinting process. So you want to understand what makes this application unique when you look at it. Outside the vulnerability entirely, you want to understand, how do I identify if this IP address, this subdomain, this domain that I'm hacking on is hosting a Citrix ADC or the NetScaler. So again, this is how I would personally do it. I would go based on the web page because I'm not going to scan the entire internet. I'm only scanning subdomains of bug bounty programs. So I'm going to actually look for these keywords in the response header and the source of the page while I parse it, and also make sure that the title is set to Citrix login. So we talked about identifying this application when we're scanning. The next step is to either exploit it or automatically exploit it on our own. I'm not going to automate this for me. I'm just going to purely look at, for this video at least, I'm going to look at how do we exploit this and how do we get it to work. So let's get into that. So the first thing that I've noticed based on all the tweets and news article that I've read is that this is a super simple and straightforward vulnerability, and it doesn't take too many attempts and requests to make it work. So in other words, there are only 2 requests that you have to make in order to fully exploit this. The first request is the post request you make to create the template, and obviously the second one is where you traverse out and fetch the file where it has the output of your command. So let's look at this POC and see how it works. In the first post request, you want to make a post request to /VPN /VPNs portal scripts new bm.pl, which allows us to create a template based on the description. So what you want to do is you want to give it a URL that could be arbitrary, anything you want. The title is important. You want to make sure you give it a title where you can actually fetch the file later on. And obviously the description is where we put our command. So for this example, I'm going to just have it give us a uname and tell us where this machine is, and write the output to a file called NahamSec POC. And NahamSec POC is also mentioned in another area for this request. As you can notice, there are 2 headers that stand out. The first one is NSC user, and we're traversing out of 4 folders by going .. Netscaler portal template and giving it nahamsec.poc, so we can actually fetch or create this file where it would store the output of our command. The second one now is where we actually read the content of the file where it has the output of the command we made in our post request. So for this one to work, what we're going to do is, again, we're going to use those same 2 headers, NSC user and NSC nonce. But what we're going to do is we're going to make a GET request this time. And within the GET request, again, we have to go to VPN /.. VPNs portal / whatever file we use. For this example, I use NahamSec POC and give it an XML to make sure we can actually open it. So I assume that somewhere in this, the template that we just created gets stored as an XML, and that XML file is where it, save the output of our command using the template that we created in our past request. Again, these are all based on assumptions that I'm having based on reading Corbin's tweet, some of the other POCs, some of the articles that I've seen, and it looks like we have a working POC. But for us to understand this even more, I actually reached out to Corbin, CDL. You can follow him on Twitter at @hacker_. I'll leave his Twitter link profile down below. But I asked him to give us a thought process from his end. What was his thought process to create this? So let's talk to him and see what he has to say.
I came across this post by Sands, which is about some of the scanning they were seeing for this vulnerability on one of the honeypots they had set up. So we see in here, there's a few basic scans that they saw. So we have just VPNs. This SMB comp phone had been on Twitter for a while. It's a more exciting request. And then at the very bottom, as this request doesn't trigger an exploit the way it is written and wouldn't work as is, but it hits one of the vulnerable URLs. So this was really interesting to me. So I set up an instance and decided to just look at the source of this script. So let me pull it up for a quick second and let's just look through it to try to get a basic understanding of what's going on here. We notice that right here, it expects a post request. And then it's also expecting these URL parameters. So we have URL, title, desk for description, and UI in use. And then we see they're doing some replacement of characters to prevent against cross-site scripting attacks within these bookmarks. And then further down, we see they're doing some more validation on URLs. And eventually, what happens down here is it actually writes this bookmark to the file system. So I was immediately thought, hey, let's try making this post request with these parameters and see what happens, right? So here I have my lab set up and let's try to make a request to this. So we see that it needed a post request, right? So here we did post. And then we send all the URL parameters, all the parameters that it's expecting. So we have URL. So let's give it example.com. Title, test 1, 2, 3. A description. And then we can leave off that other parameter that was there. So when we make this request, or initially, when I made this request, I saw that I was still getting an error back. And so I went back into the script right here and looked at the very top. And here we see these two subroutines that are called. So we have this user prefs new and then this CSD subroutine called. So when we grep for that, let's do sub new. We see there's user prefs, which is, we can see was called earlier. So when we look at this, we see that nothing's really going on here, but the CSD subroutine is a lot juicier. So right here on line 21, we can see that it's actually expecting a HTTP header to be sent, and that HTTP header is NSC user. And then also down here in the session initialization, it's expecting an NSC NOTS header as well. And then what's most interesting is that it's actually taking the NSC user header, taking a directory, taking this header that we control, and then appending .xml, and writing that file to the file system in that bookmark directory. So when we do NSC user, let's do CDL NSC nonce CDL and try posting this again, we can see that we don't get that error anymore, and it actually writes it to the file system. So when I go into my lab here, let's see what directory I'm in. Let's go to var VPNs. I think this is the directory. Let's see, var VPN bookmark. So when we see right here, we have that cdl.xml, and when we cat that, we can see that this is the description, the title, and the URL that I sent. So it actually creates this bookmark into the system. And then let's just remove these two. So what's interesting about this script as well is that there's no protection against a path traversal. So what happens when we try to traverse back a directory out of this bookmark directory? Let's see. So if I do NSC user ... which means go back a directory, and then send it again, we see that this request still works. And when we're in this directory behind bookmarks, let's do ls, and we can actually see that the CDL XML file was actually written there, and it traversed back. So the next part for me to figure out was there was another blog post. Let's see, Tripwire. There's another blog post about getting RCE, and this was about the. We can see right here. I could now write an XML file with limited user-controlled content and in the location the web server process can write. Despite this, there was no clear way to go from XML file to a web shell, but was able to load the crafted XML through the Perl template toolkit. So next what I did is I pulled up the documentation for the Perl template toolkit just so I could see what basic usage looks like. So right here you can see some very basic Perl that is using this template engine. And right here you'll see template-new. And so what new is it is a constructor. So when that's called, it returns an object that is an instance of template. So essentially, if developers want to do any templating with this, they're going to need to call this constructor. So knowing that, I decided to grep this string through all the Perl scripts that were in that portals directory. So when we look for that, we see there's several Perl scripts that have that within it. So I spent a long time trying to see if I could get my XML file to pass through the template processing calls within them, but none of them worked. And the reason I wanted to do this is because since I can control some of the content within the XML file, if I could put a little malicious template in it, I could likely execute code. And so, like I said, none of these three worked. And so then I moved on to this handler Perl module. So as we can see here, mod Perl, which is just a module for Apache, allows us to use handlers. So handlers are simply Perl subroutines called by the server at various stages of the HTTP request cycle. A content handler is a subroutine that is called by the response phase. So let's look at the HTTP configuration for Apache on this ADC application. So we find this location directive within the configuration file that basically says if there's a HTTP request with the URL path that starts with VPN's portal, it'll defer that request to the handler subroutine, which is defined in here. So knowing that, let's look at it. So what it's doing is it's taking the full request path and just taking the file name, or the template file name, and it tries to find that template within the template directory and then render it and return it back to the user. So if we can write an XML file with malicious template directives in it, we can get that rendered by this template engine. So after digging through more source code, I found out that this template directory was at Netscaler portal templates. So if we do an ls in here, we can see that there are a bunch of templates and HTML files that are being served back to users from this directory. So next, what I did is I just tried to traverse back to this templates directory and see if I can get my file in there and served back to me. So as we see here, we try to traverse out of the var VPN's bookmarks folder and into the Netscaler portal templates folder. And let's name the file cdl.xml as it automatically appends the XML extension. So we go ahead and send that request, and as we can see, it successfully writes it. So next we take that cdl XML file and see if we can get that served from that VPN's portal directory that we talked about earlier. And as we can see, it actually does write that XML file to that folder and serves it back to us. So I found what the basic template syntax looked like and decided to try 14 divided by 7, which is 2. So I tried that and tried to add that to the CDL XML file that I previously wrote to. So now, when we request cdl.xml again, we can see that rather than showing us what we sent it, which is 14 div 7, it actually processes that template and returns the result back to us. So as I was reading on in this article, I read that it said the eval Perl option was disabled. So what eval Perl is that when it's enabled, it allows developers to create templates with Perl code in between two template blocks that look like this. While this is disabled by default, there is a loophole that still allows us to execute our own Perl within a template. So here we see the template new constructor being called with block and then some Perl code after it. So if we can call the new constructor within a template, we can get code execution. So let's try this. Let's do template.new. And then let's take this block and then try to pass in some of our own Perl code. So let's go back to burp and try block, this operator, and then print, and then CDL. So let's URL encode it and send it again. So let's load it. And as you can see, we get an error. So let's look at it. So as you can see, it says file error, parse error, cdl.xml, unsupported token and. So if we remember from earlier, the new BM Perl script is doing some encoding on certain characters to prevent against cross-site scripting attacks. And one of these characters is the greater than sign. So what we can actually do is we can actually just delete this greater than sign and it'll work. So let's write to a different XML file since that one has a corrupted template in it. Let's URL encode this and send it again. So let's load it again. And as you can see, it actually executes that Perl and prints out CDL. So finally, what we can do is actually just use backticks to execute code. So let's do cat etsy password and URL encode that. And let's write it to a different template file since the other one's already corrupted, and send it. And let's load it. And as you can see, the command executes and there's the contents of Etsy password.
So this was a very last minute video. I didn't make plans to do this today, but seeing all the tweets and all the news that are coming out because of this NetScaler bug or the ADC, whatever you want to call it, I really wanted to cover it and talk about why it's so important and also show a working POC. And I'm very happy that I actually got Corbin to join me and explain his thought process. Again, if you're not familiar with my channel, please give it a thumbs up, like and subscribe. And of course, every Sunday I go on Twitch where I stream my hacking process for a few minutes, and then I bring on a guest where they talk about their process and how they do hacking when it comes down to bug bounties. So if you want to come interact with me live, make sure you check it out on twitch.tv/NahamSec, and I'll also put a link down below so you can actually get access to it. Again, thank you so much for watching this. Leave me some comments. Let me know if there are other CVEs, bug types, or topics you want me to cover. But until the next video, I'm out. Have a good day, have a good night, and I'll talk to you all later. Peace.